Agile monitoring and reporting. Agile monitoring and reporting. Introduction to burn down and burn up charts. In the realm of agile project management, visibility into the progress of work is paramount. To this end, visual tools like burn down and burn up charts are employed to provide a snapshot of the team's progress against planned work. These charts are crucial for gauging whether a project is on track, and if not, where adjustments needs to be made. Now, what is the burn down chart? What is a burn down chart? A burn down chart is a graphical representation of work left to do versus time. And the primary purpose is to project how quickly a team is burning through its backlog. And what are the key components of burn down charts? The key components of burn down charts are the y-axis, which represents the amount of work, the x-axis, which represents time, typically days in a sprint or iteration, diagonal line, which is the ideal line showing the projected pace of completing tasks, actual line, which reflects the real-time progress of tasks completed. How do we read the burn down chart? How can the burn down chart be read? Now, if the actual line is above the ideal line, the team is behind schedule. If it's below the ideal line, the team is ahead of schedule. Now, what are the benefits of applying or making use of the burn down chart? First, it helps in identifying if the team is on track to complete the planned work. It helps to provide a clear visual indication of any discrepancies between planned and actual progress. Having discussed the burn down chart, what is a burn up chart? Burn up chart. While a burn down chart focuses on what is left, a burn up chart focuses on what has been accomplished. It graphically represents the cumulative work done over time against the total scope of a project. Again, it graphically represents the cumulative work done over time against the total scope of a project. The key components of burn-up charts are the y-axis, which represents the total amount of work, both completed and pending, the x-axis, which represents time, the scope line, which represents the total amount of work identified for the project or sprint, the work done line, which shows the cumulative work completed over time. How do we read the burn-up chart? The gap between the work done line and the scope line provides a quick view of the remaining work. If the scope line moves upward, it means additional work has been added. Now, what are some of the benefits of the burn-up chart? The burn-up chart provides a clear picture of the overall project progress. It allows stakeholders to understand how changes to the project scope affect the completion timeline. Comparison. While both charts provide valuable insights into the progress of a project, they offer different perspectives. Burn down chart focuses on the work remaining and how quickly it is being tracked, or it is being tackled rather. It focuses on the work remaining and how quickly it is being tackled. While burn up chart emphasizes the work completed and the total scope, giving insights into scope changes and overall progress. Cumulative flow diagrams for Kanban. In the dynamic world of project management and agile methodologies, visualization tools play a pivotal role in ensuring smooth processes, clear communication, and timely delivery. Among these tools, the cumulative flow diagram, CFD, cumulative flow diagram, has emerged as an invaluable asset for teams using Kanban. Now, what is a cumulative flow diagram? A cumulative flow diagram is a visual tool used in Kanban and other agile methodologies to represent work items as they move through various stages or states. It's a stacked area chart that shows the quantity of work in different status over time. Structure of a cumulative flow diagram. At its core, the CFD cumulative flow diagram consists of several colored bands, each representing a particular state of work, such as to do, in progress, and done. The horizontal axis denotes time, while the vertical axis denotes the number of work items. Now, start point. The start point is usually on the left side of the diagram, marking the commencement of the project or time frame. It is one of the components of a CFD. The next component is bands or lanes, and this depicts the status or states of tasks. The width of each band at any given point on the x-axis indicates that the number of tasks in that state at that time. Again, the width of each band at any given point on the x-axis indicates the number of tasks in that state at that time. The end point. The far right of the diagram represents the present or the project's conclusion. Interpreting a CFD. The lead time. The horizontal distance between when an item enters the to-do state and exits the done state gives its lead time. But by observing the average width of the in progress band, you can determine the average lead time. Work in progress, WIP. This is the number of tasks in the in progress state at any given time. A widening in progress band indicates an increasing WIP, which could signal problems. Bottlenecks. If any band consistently expands over time, it signifies a bottleneck in that state or phase. Flow balance. A well-balanced process will have parallel and roughly equidistant bands. If the bands start diverging or converging sharply, it indicates imbalance. Why use a CFD? Why do we need a CFD? The first use of a CFD, cumulative flow diagram, is to ensure visibility. CFDs provide a clear snapshot of how tasks are flowing through the system. This transparency helps in early detection of bottlenecks and inefficiencies. Second, predictability. By analyzing trends in the CFD, teams can make educated predictions about future performance and delivery dates. The next is improvement over time. Regularly reviewing the CFD can highlight process improvements or regressions, guiding teams to make necessary adjustments. Stakeholder communication. CFDs can serve as an effective communication tool with stakeholders, offering a visual representation of the project's health and progress. Tips for effective CFDs. The first tip is regular updates. For a cumulative flow diagram to be useful, it should be updated regularly, ideally daily. Limit states. Avoid having too many states as it can make the diagram complex and challenging to interpret. Third, review and act. Regularly review the CFD with the team and take actionable steps based on insights. The fourth, combine with other metrics. Use CFD in conjunction with other metrics like cycle time, throughput, and lead time for a comprehensive view. Agile metrics, velocity, cycle time, and lead time. Agile methodologies, particularly Scrum and Kanban, have transformed the way software development and product management are approached. And these methodologies prioritize adaptability, iterative progress, and customer feedback above all. To measure the effectiveness of agile practices and make necessary improvements, there are several key metrics that teams often rely on. Among these metrics are velocity, cycle time, and lead time. Understanding these metrics is essential for any agile practitioner aiming to improve their team's efficiency and deliver value to their customers. The first of this metric is velocity. Velocity is a metric used primarily in Scrum to gauge the amount of work a team can complete in a given iteration or sprint, which typically lasts 2 to 4 weeks. How is it measured? Velocity is calculated by summing up the story points or any other units used for estimating work of all the user stories completed within a sprint. For instance, if a team completes 5 user stories in a sprint with respective point values of 2, 3, 5, 8, and 5, the velocity for that sprint will be 23. Why is it important? Velocity helps teams predict how much work they can realistically achieve in future sprints. By tracking velocity over multiple sprints, teams get a clearer picture of their average performance, which aids in better planning and forecasting. Velocity is team specific and shouldn't be used to compare the performance of different teams. Additionally, it is important to focus on consistent and sustainable velocity rather than pushing a team to continually increase it, which could lead to burnout or sacrificing quality. Before we proceed, kindly take some few seconds to subscribe to our channel by clicking on the subscribe button on the screen. Kindly subscribe to our channel by clicking on the subscribe button on the screen, either on your left hand side or on your right hand side. Kindly do so. Kindly click on the subscribe button on your screen, either on your left hand side or on your right hand side. Also click on the notification button to be notified whenever we release new videos such as this. Click on the notification button to get notified, to be the first to know when we release news videos such as this. Kindly do so within some few seconds. I'm waiting for you to do so if you have not done so yet. Thank you so much. Now we proceed. The next metric is cycle time. Cycle time is a metric predominantly used in Kanban but can be applied in any Agile framework. It measures the time taken for a work item to move from the start point to the completion point within the workflow. How is it measured? The clock starts ticking when the team starts actively working on an item and stops once the item is complete. If it takes 7 days from when a task begins to when it is completed, then the cycle time is 7 days. Why is it important? Understanding cycle time allows teams to identify bottlenecks in the workflow and improve efficiency. A consistent or decreasing cycle time indicates a streamlined process, while an increasing cycle time may signal issues that need addressing. Now, external factors like dependencies on other teams or waiting for external feedback can affect cycle time. It is essential to differentiate between active work time and waiting time when analyzing this metric. Lead time. Lead time starts the clock earlier than cycle time. It begins when a new work item is created or requested and ends when the item is completed. How is it measured? It's if a future request is raised on the 1st of a month and is completed on the 21st, the lead time is 20 days. Why is it important? Lead time gives stakeholders an understanding of how long it takes for a request to be fully realized. A shorter lead time can indicate a responsive and efficient process, enhancing customer satisfaction. Like cycle time, lead time can also be influenced by external factors and periods of inactivity. It is crucial to dissect the lead time to understand which portions of it are active work and which are waiting periods. Continuous improvement with Agile. The landscape of the modern business world is characterized by swift changes, fierce competition, and a relentless quest for excellence. In such an environment, the ability to continuously improve is not just beneficial, it is imperative. Agile, a methodology rooted in software development but now prevalent across diverse industries, across diverse sectors, provides a roadmap for continuous improvement. Now we will learn the connection between Agile and continuous improvement. What is continuous improvement? Continuous improvement is a systematic, ongoing effort to improve products, services, or processes. Improvements can be incremental, which means small and continuous changes, or breakthrough, such as major changes. The philosophy behind continuous improvement is well captured in the Japanese concept of kaizen, which means change for better. In essence, no process is ever seen as perfect. There is always room for improvement. The Agile approach. Agile methodologies like Scrum, Kanban, and Lean emphasize adaptability and collaboration and delivering value. Rather than following a strict plan, Agile teams are built to adapt based on feedback and changing circumstances. This natural alignment with continuous improvement principles is the primary reason why Agile has gained widespread adoption. Principles of Agile that foster continuous improvement. The first principle is iterative development. Agile methodologies like Scrum break down projects into small increments or iterations. After each iteration, the team reviews their work, which allows for frequent adjustments based on what was learned. Feedback loops. Agile practices encourage regular feedback from stakeholders, including daily stand-ups, sprint reviews, and retrospectives. This feedback helps identify areas of improvement in both the product and the process. Adaptive planning. Agile teams acknowledge that requirements can change. Instead of resisting change, Agile frameworks have built-in mechanisms to adapt to changing requirements, ensuring that the product remains relevant and valuable. Team collaboration. Agile promotes a collaborative environment where team members frequently communicate and share ideas. This collaboration leads to innovative solutions and shared responsibility for improvement. Value-driven development. Agile teams prioritize tasks based on value to the end user or stakeholder. This constant focus on delivering value ensures that improvements are aligned with user needs and business objectives. The role of retrospectives. One of the most powerful Agile practices specifically aimed at continuous improvement is the sprint retrospective. At the end of each sprint, the team gathers to reflect on the past iteration. They discuss what went well, what could be improved, what they will commit to improving in the next sprint. This structured reflection ensures that lessons are learned and are applied, resulting in iterative and incremental improvements. Challenges in achieving continuous improvement with Agile. The first of this challenge is resistance to change. Humans are often resistant to change. Adopting Agile and embedding a culture of continuous improvement can be challenging and requires commitment from all levels of an organization. The second challenge is lack of metrics. To improve, teams need to measure. Without relevant metrics and key performance indicators, it becomes challenging to identify areas of improvement. The third is complacency. Once Agile practices are adopted, there is a risk that teams can become complacent, thinking that they've achieved Agile. However, continuous improvement means that there is always room to refine and enhance processes. If you haven't done so yet, kindly subscribe to our YouTube channel by clicking on the subscribe button on the screen. Also, click on the notification button to get notified of our future videos. If you find this video especially helpful, please do not hesitate to like and share with your audience on social media.